All right, we're going to take a look at how we can add a for loop into our Python code to repeat the code over and over again so that we don't have to type our code over and over again. We'll use a turtle to demonstrate this. So we'll do a title for loop, and we'll do our standard import turtle. And from there, we'll set up our screen. And then after that, we'll name our turtle equals turtle.turtle, capital T turtle. And that'll import turtle into our program. Next thing we're going to do is let's set our screen BG color, background color to be black. Good. And let's change our turtle dot color to be white. Let's change our turtle dot speed to be fast. Okay. If I was going to have a turtle draw a square, let's start with that. Let's define a function called square. There we go. And we'll have it do turtle.forward 50, turtle.right 90, turtle.forward 50, turtle.right 90. Okay. So if we run the code, we should see our turtle do nothing because we made the mistake of not calling the function. There we go. Okay. So turtle went forward, went right, went forward, went right. Okay. I'm going to actually back off on this to be... Nope, that's not something. I'm going to delete this right now. Okay. I want you to see it happen. Okay. So we have it go that way. I'm going to take these 4 lines because it's a square and we've drawn half of it. We should be able to just copy these lines to the other half and have it repeat for us, right? We run it. We see that the turtle is going to be drawing an entire square for us. This is good news. Okay. Next up is let's go and now if we want to have this turtle draw the same square over again, we could just do another call to square. This isn't really all that exciting, to be honest with you, watching it repeat the same shape over again. So let's do something a little interesting here. Next to square, or after the line of square, after line 19, let's do turtle right, and let's have it turn by just 5 degrees before it draws the second square. Okay, we start to see a little interesting shape come out. So if we want to draw something like a spirograph, we can use what we've done so far, right? And as long as we just keep on doing, let's see, I'm going to take turtle right, 5. We could take these lines and bring it to the next and paste it a couple more times. And what we'll see is the turtle will start drawing a spirograph, which is pretty cool. Pretty neat shape. But what if we want to do this shape, say, 100 times? Well, we could simply copy and paste this code over and over again. But how do we know for sure that we've copied it exactly the right amount of times? Or what happens if we want to subtract maybe 25 times? Do we then count out the amount of squares and rights we have? This seems really inefficient. And in fact, it violates one of the programming fundamental beliefs that you should not be repeating yourself. Do not repeat yourself. And we are definitely repeating ourselves here. So how can we solve for this? Well, we can use a for loop. And what a for loop is going to do, the syntax is going to be for n in range. Okay. And what that means is this is just a variable. And it's just meaning what is the thing you're drawing over and over again. So typically in Python programming, n is used, but it could be any letter you want, literally any letter. It could be a name of something. It could be square in range. N is just the go-to. And then we say for n in, and then we say what we want, how many times we want to do it. So here we have a range, and we could set the max number of times we want to have it done. So this here we're just going to do 10. We do the colon, we hit enter, and it should automatically tab it in. If not, just tab it in. And then inside there, indented underneath the for n in range loop, we get to tell it what we want to have it do over and over again. So in this case, we want to have it draw a square. And then we want to tell it to turtle.right and 5 degrees. Okay, so now what I'm going to do is I'm going to go up here and I'm going to do back up here. I'm going to do turtle.speed. We're going to make it go fast. And here we see the turtle start to draw its spirograph over and over again. Pretty cool. What happens if we increase this number to 100? We see it start to draw and go right around, drawing a really cool looking spirograph. Now, how many numbers is the right number there? Well, you can just sort of guess and check and see if the image comes out looking like you want to. If it doesn't, then increase the number, right? If it's too much, if it starts to overlap, then you can simply decrease the number. But the point here is that we do not have to check through all of our turtle and turtle.right and square lines to see where to just basically count them out to see which one's the right one. We could just change this number and it results in really fast just coding, testing your code. Now, could we wrap this in a function, right? I mean, right now we don't have to do anything with this, right? But if we want to make it nice and neat, we could do something like define draw all squares, something like that. And we can just simply take this. I'm just going to copy it, move it down here, indent it in one to put it under that draw all squares. And then over here, we can just call that draw all squares. And that gives us control over when those squares are drawn. Okay. And then if we call draw all squares, it should do the same exact thing as before, just draw all those squares. But now it gives us a little bit more control over that little bit of program, wraps it in a function, right? Keeps it from polluting the rest of our code in case something goes wrong. All right. And this makes sure that you took your, possibly, if we're going to do this 100, right? 100 times 2, that would have been 200 lines of code that it would have taken to draw out turtle square and turtle.right. We condensed that all to 3 lines, and that is some pretty good condensing of code there. All right, that's going to help you out. Okay, that's it for this one, and I hope you now realize how you can use for and in range to make your life a little bit easier as a coder, make your programs a little bit more clean and easier to read, interpret, and to write.